I'm Dr. Salehi, and I'm about to create a number of short video talks about artificial intelligence, computers or agents, machines, and we'll explain in a very simple language, um, understandable by masses of the audience, about how they make them, how they work, what is their potentials, what is their limitations, etc. What made me interested to create these videos is because after this chat GPT was introduced all over the world, masses of people began to realize that we are about to have kind of technologies that behave like humans and maybe even more superior to humans in some respects. And to them, it looked like magic what this amazing machine does. Although, since the introduction to people is through mass media, and mass media is not academically oriented, but more in terms of market oriented for attracting audience and keeping them pleased and feed them what makes them entertained. The chances are that what they have introduced would be to an extent mixed up with science fictions and their personal understanding, which may not necessarily be technologically reliable. However, what happened which made this idea of these kind of machines being used and maybe used more extensively in society very exciting is because it was not all positive talks. People who know what they are talking about technologically, some of the top personalities in computer industry, and some of the people who were very involved with the creation of these artificial intelligence machines began to alarm us that the chances are that in future, now maybe it would be a little bit far distant future, if technology of artificial intelligence advanced the way it's already doing, it could endanger humans and societies. And so this kind of a mixed feeling of positive and negative and talks for and against it has generated more interest from people of all walks of life, including someone like me who's dual majored, to get involved because I happen to be a professor of sociology for 15 years, but prior to studying sociology, I had already received the degree of electrical engineering from Purdue and switched out, went to Michigan State. And my sociology was more about modern societies, especially the ones that technology and industry plays a major role in them. And then at some point, I became kind of cautious that if technologies advance the way they do, pretty soon I might be able to know what was in the past, but not know much about the future societies or the future of societies. And therefore, I just quit teaching and became a student again, graduate student. And my purpose was to learn about highly advanced technologies of the day, which obviously they were all computer-centric and digital communication, things like this. So I got a degree in mathematics first, a master's of mathematics, and I spent a few years taking all relevant courses in graduate school of computer science and a few years in PhD level courses at engineering school. Included were courses about design of artificial intelligence computers and these kind of intelligent devices. So, given the fact that the new interest in artificial intelligence is not just purely technical, but technical and social, I found myself in a position that might have something to say, and some people may benefit from it. But today I'm going to answer some basic questions and devote the rest of the time to these questions. Questions are, how does this technology differ from others? Like, how does an intelligent computing machine differ from an ordinary computer? Why we call it intelligent? What is its characteristics that makes it behave intelligently? Where did the engineers and technologists who created these machines get their ideas? And these are the kind of questions that when they are answered, people start to see what kind of techniques are involved and what kind of outlook perhaps they could have about future of artificial intelligence machines. Usually in academic circles, they don't call them artificial intelligence computers, they call them artificial intelligence agents or applications. First, these machines behave like humans in terms of some intelligent aspects of duties which is assigned to them. However, they do not think. No machine that we have created or will be able to create based upon our current state of mind, of technical mind, could think. Thinking is unique to humans because it's a highly complicated process. And these machines are processors. They process a task, although in a very interesting way. The second is they are intelligent. They're called intelligent because they behave in some respect like humans. For example, they don't make these artificial intelligent devices in the stores. You go buy like a computer or a radio or a TV set and bring home and let it work. They are more like hiring an employee in a company. For example, they want to do certain tasks. In order to perform those tasks, they design an artificial intelligent device in a raw form, and then they train it, and they sort of do what they call machine learning to learn the task and how to perform it. So it's just like hiring a person for a job, training it, and when the person is trained, you put it in that position. And actually, a simple example will show you how. Suppose instead of hiring a telephone operator in a company, they just have an artificial intelligent computer made for them that is taught the name of all the departments and bureaus of that company. And then when people call, the calls go straight to the software, to this computer. And the software listen and understand what people say, even though they have different accents and different tone of voice. So it's intelligent enough to distinguish what they say, and then rest of the communication system and the computer system, we take the advice or the decision and then connect the person to where it should be connected. So this computer, this artificial intelligent device would be like a software that embedded in the rest of their communication and telephone system or computer system. Usually they are starting from a some drawing on the paper, um, a bunch of what is called artificial neurons, that they mimic the neurons of human brain. They put them in a network, and that's the way the first step is. If you look at here, this is a real neuron of the brain. It looks like this. And the bottom one is a very simple form which mimics that. It's a circle, an input, and an output. And when they link them together, make them a net, they call them neural net, which is the basis of these computers. A neural net would look something like this. You see, every of those circles is one of those neurons. 2 lines gets out of it, or maybe more lines, because the output goes to different neurons. The neurons are all interrelated. So in the first line, there's only one line going into it, and that's the input. And the output is one line coming out of every neuron that exists. But in between, there are layers, in between layers, hidden layers, that they, in a variety of ways, all these neurons would be interconnected. And they make a solid piece of network. Now, what it does, this machine, when they draw it, this drawing, they write a computer program to simulate this drawing into a reality, or at least an image of a reality. And then they input something, and they check the output. For example, if this machine is made to read handwritten alphabet letters of English, they show it, or they enter into it information about a handwriting of letter K. And when it goes through with the speed of light, at the end, for example, it identified that this was letter F. Well, it's a wrong, right? A wrong identification. It didn't do the job. So what it does at this moment, a very complicated mathematical algorithm in the computer evaluates that every one of these neurons, which there's a number called weight in them, and arbitrarily at first they put those numbers, how much every of these weights should change. Suppose if this neural net has 2,000 neurons, you have 2,000 weights. Every one of these weights should be changed a little bit, modified. Then they go to the next experiment. They write the handwritten of somebody else who wrote like L. And again, if it could not identify it properly, it was wrong. That algorithm computes that how much more that W's, or those weights for every neuron, has to be changed. These changes are very tiny, like maybe 0.0005, like 5 out of 10,000. 10,000, very small. So when they repeat this kind of experimentation, and followed by computation and modification, gradually the weights become close to what they should become eventually. So you see that now maybe 20% of the time this machine identifies things correctly. You put the R and it recognizes it. It says it's R. So it did a good recognition. And then maybe another experiment, till eventually after 10,000, like 15,000, 20,000 trial, it start to work perfectly. It means make very few mistakes, or maybe just one mistake in 1,000 or in 500. Then you think the system has learned its task. It's machine learning. The system now knows what the task is and how the task should be performed. Then they quit the training or machine training, and whatever number is for W, that gets fixed and consolidated. And that network that I showed you, and once again I show you, if you put those weights in those circles or assign them to every circle its proper related weight, now the machine is artificial intelligent performing instrument and knows its task and performs it. This is the foundation of all of them. But what does those W's mean? What those lines mean? Well, all would be about memory and memorizing, and somehow consolidating what is learned. You see, we human beings remember things that we have learned. If we sleep at night and wake up in the morning, we are the same person who went to bed. We remember things. Have you ever asked yourself, what we learned, where does it get stored? Is there a memory, like a computer, like a hard drive, somewhere in our body, that all this knowledge and all these techniques and habits that we have, personal habits, are stored there? For example, if we close our eyes and someone put in front of our eyes the picture of a rabbit and say, open your eyes. As soon as we open, we see it's a rabbit. How does it happen? Does something in our head go to that memory somewhere, that the storage somewhere, and look at all the images of animals that we have stored there and compare it with this one and come up and say, oh, this was rabbit, the picture of a rabbit. Well, a digital computer has to do it that way. A digital computer is not intelligent. If they put the image of the rabbit among many others in its memory, in digital form, like changed into 0 and 1 binary numbers, and then a software would go and look through and all of the existing pictures and compare it one at a time with this one, and if one of them exactly matched it and it happened to be written onto it, for example, rabbit, the result comes that, oh, that's the picture of rabbit. But this kind of thing doesn't happen in our head because we don't have this kind of facilities. So where is that stored? Well, this information about things that we learn, the habits and etc., or knowledge, they get stored because when it's repeatedly known, the information gets to the seed or center of neurons, and then if it's strong enough, they fire or they send a signal through their output line, the output line that I showed you once again, this one, and this one, no, yeah, this one, and these are the input ones. And then what it does, it goes to the, it connects or associates itself with the neighboring neurons, and they may even have the same information or part of this information, and they join their strengths together and become input to another neuron, and then this kind of process happen. And when a series of these neurons at different levels sort of act, finally an action, the order for an action is given, that for example we close our eyes or open our eyes or do something, some body actions. So memory is there because when something is repeated over and over, those links, those outputs get strengthened, and the relationship with the next ones or the neighboring neurons and working together become consolidated, and then it's remembered. It becomes like, something that is become a part of our body, part of our brain. So this is the way they do. Although I'm not an expert in the field, but I've read quite a bit. If you want, you could go and search in Google for neurons and how they work, and you will find very interesting material to read. But the engineers who made these computers, they read about this behavior of the neurons and they tried to mimic it, and they made a simple neuron like a circle and two lines going into it. Obviously, the neurons, when they change in the body, is something like a growth. But in reality, in engineering, we cannot have a technology of growth. When we use a wire, for example, as an output, that's it. It doesn't change unless we replace it. So what they did, they put that weight in that circle, because the weight multiplies with input and becomes how much the output will be. So this way, they could make the output to vary. And by doing this, eventually, when those weights are decided, all of them properly, the machine has already stored the information, and what is learned is stored, digested, stored in the way it is interconnected and in the way those weights are or how much they are. And that's it. So this machine doesn't have any memory, the hard drive or something like computers. It doesn't have chip or main brain. It's very simple. It's just what I showed you, except that, you know, those values of W is chosen and system is tuned up. And that's exactly the way they make them. The more complicated ones have more layers and more neurons, and there are some differences in the way the neurons in different layers are interconnected. And they have a very extensive learning process. They call it deep learning. Maybe tens of hundreds of thousands of samples are tested to the point that the machine has a more experience and learned a lot more than the simple ones. And they could do very fascinating works. For example, they are used now, or they could be used very soon in medical field to read X-rays. For example, identify or diagnose if a patient has a certain disease. They could be used in business, in industry, for different purposes. Already in linguistic, they are very good. They could do linguistic analysis and things like that. One area that they differ is that to what degree we have control of these systems when we make them, how much we define their task. They called, some of them are sort of like less control of the people on decision about their output, and one they have all of it decided. For example, if you make a machine to identify the alphabet of English in handwriting, well, the output is limited to the letters, number of letters. And we decide for that. The machine works within the, our decided or within our authority. But if you make a machine like an automobile that runs itself, well, then when they made it, they let it in the street and that's it. It's not connected anywhere. It just operates by itself. And it's that will become scary if the task is not just a car to drive, but let's say, for example, a war machine, a system of war machine that is intelligently deciding what to do. And we will talk about those in other videos. In next video, I try to be more toward explaining a little bit about how the more complicated ones are made and how they actually receive the input.